Hello everyone, today I'm going to deliver a lecture on bearing capacity of pile. So the topics will be covered. At first I will try to deliver the theory and formula of the bearing capacity pile, and then the skin friction or resistance of pile or clay soil and skin friction or resistance by sandy soil, and then bearing capacity of pile, sand and clay soil. This is the very important. So using Terzaghi method, and bearing capacity of pile, sandy and clay soil using beta method. So these are the different method we will cover, um, and this lecture will be very important. I'm highlighting the red color, that's why. And then we'll try to the theory and formula of the group pile. So this is the group pile. Group pile bearing capacity, and then bearing capacity of group pile using efficiency method and Terzaghi method, and we will compare the which method is good. I hope that the efficiency method is good. We'll see. And the maximum and minimum vertical load of group pile. So let's see. So first of all, I'll covering the theory and the formula of pile bearing capacity. Okay. Okay, so we can see here the pile foundation when the footing, uh, when the soil bearing capacity is very low, and the below of the footing, then we will use the pile foundation. So you can see here is a pile which is inserted into the ground, and the surface, we can see the contract between soil and pile in the surface. This is the skin friction. So skin friction will take the surface of the pile. And second one, we can see the end bearing pile or tip bearing pile will be taken the pile at the bottom, not the surface, or nor the upper level. So it will be take that at the end of the pile. So we can call this the end bearing resistance or tip bearing resistance. When pile is going to the downward, then skin friction will be increased. Okay, so this is the main formula we have to must be memorize. The ultimate bearing capacity of pile QU, which is trip bearing and or end bearing, and the skin friction. So let's see. QU equal to, we have divided the two type. So first of all, C is 9, and AB, which is clay soil, and Q and Q star AB, which is for sand. So this is the end bearing, and the skin friction alpha CUAS for clay soil, and 0.701 minus 0.5 sigma vertical 10 phi into psi. This is for sand. So this portion is for end bearing, and this portion is for skin friction. So let's see the end bearing, which is QB, where I'm writing here details, which is QB equal to C and C star A plus AB plus Q into and Q star into AB. So this is for clay. So NC we are taking for 9. This is always for 9, and Q star AB. So what is AB? AB is nothing but it is the area of the pile. If the pile is circular, then pi d square 4. As usually pile is circular, that's why we will use this formula. In the case of we will install the rectangular pile, then it will be area of rectangle B into W, which is a cross section area. So for clay, how will recognize the clay? When the phi equal to 0, then we will recognize the clay. So QB equal to 9C into AB, and NC star, the value of NC star 0.829. So we will use always 9. This is the memorizing point. For sand, when C equal to 0, then we can recognize this this soil is sand. So q and q star ab. So n q star will find the from chart, will see how we'll get the n q star, and q equal to gamma prime l. L is the length of the layer of the pile, and q allowable ultimate divided by factor of safety. We know the factor of safety always we are taking 3. So the second part we will see this portion, which is the skin friction or shaft friction or skin resistance, which is alpha cu as 0.70 1 minus psi phi alpha. So let's see as what is the s. S is nothing but the perimeter into length. So perimeter equal to the for the circular column pi d into l into length of the pile. So all the pile are circular section, that's why we will use this formula. In any cases for our research purposes or any special cases we use the rectangular pile, then we will use this formula b into w into 2 into l. But the all the concept is remain same, which is perimeter into length. Okay, let's see for clay. We know when phi equal to 0, then thus the soil is recognized clay. So alpha, which is addition factor, as usually the addition factor is 0.40 to 0.60. So it is the memorizing value. And C use undrained cohesion of clay, which is Q divided by 2, which is taken from Terzaghi or SPT test. For sand, when C equal to 0, and then the soil is recognized sand. So sand will be Ks alpha vertical into 10 phi. So Ks equal to will get the value of Ks which is Ks equal to K naught, as we know, 0.70 or 0.60 to 0.70. So that's why you will use this formula. 0.70 we are taking the here, and 1 minus alpha, which is K naught we know the 1 minus alpha. So Ks minus K naught is 0.60 to 0.80, but we will use the average value, which is 0.70 into K naught. K naught is nothing but K naught is 1 minus sin phi. Okay, so this is coming from Ks. Gamma vertical is taken from overburden pressure, and 10 phi alpha. This is the chart which is 0.60 to 0.80, and we will use this. And for the critical depth, we know the is 10d for loose soil, and 15d which is a medium sand, and 10d equal to dense soil. Okay, let's see here. This is the main basic formula we will seeing here. So I'll say the ultimate bearing capacity here, another sand for clay, and in bearing. So applied load is less than it's not needed for the pile arrangement is given here. So here is the 3 pile, here arrangement, here is the 6 pile, here is the 7 pile, and here is the 8 pile, and the spacing between 2 pile will be must be 3d. D is dia of pile. Okay, so here is the ultimate bearing capacity, is a screen resistance into in bearing. The in bearing resistance or T bearing resistance. Here is the shallow foundation B. Here is the pile foundation. We can see df, the depth of footing is L, and B equal to D as the less dimension, and C and phi. So we know the equation of Meyerhoh. This is the, and we will use B equal to this, then that part will be neglected, because the value of dia of pile is very small. That's why I will avoiding this equation, and we will taking this remaining equation, which will be C into n c star plus Q equal to n q star. So we will see the how will n c equal to the fixed value, which is 9, and n q star we will find the n q star from the graph, and the in bearing QB into AB. So C the trip soil, it is coming from phi into C, and then C the value of we are known is in 9, and Q equal to n gamma into L. So here is a pile sand on resistance. We can see the shift or skin resistance when sand qs equal to as. So we know the qs equal to ks gamma prime into phi into as. So ks, we have shown the ks divided by k naught equal to 0.70 and k naught equal to nothing but 1 minus sin phi. Okay, and gamma prime equal to sigma prime equal to gamma prime into h equal to height of layer, and 0.70 plus sigma naught, and found this, and as equal to pi dl, and this is the phi. So you can see here the relation of phi, sigma into phi equal to 0.60. If we taking here, then it will be 0.66. This is the 0.66 into phi. Okay, cannot this is the value is given. Ks minus k naught is 0.70. So 0.70 we are taking k naught, and the k naught, we know the k naught is 1 minus sin phi, and putting this value, this is the final k is equal to 0.70 1 minus k naught. So the formula will be applied of the formula applied this. Okay, so this is the critical depth. We are known for the sandy soil, the critical depth is very important. When the skin fraction is always develop at the bottom layer of the soil. It's about 20 feet 50 feet like this. When the loose sand, then we will use 10D. When the medium sand, then we will use 10D. When the dense sand, we will use 12D. So H equal to Hc by 2. The critical depth is we will take the overburden pressure, vertical pressure, which is from the critical depth. So here is just some relation between SPT, soil type, and degree. So when the SPT is 0 to 4 very loose, and the degree will be less than 30, and from the unit weight of soil at 70 to 100. When the SPT is between 10 to 30, then the soil type is medium, and degree will be 35 to 40, and the unit weight will be 110 to 130. So in this way we are shown here. So QS1 will use this in this way, QS2, Q3, and like this. Okay, let's see another. Here is some geotechnical properties of correlation with the unit weight SPT. When the SPT is 30 to 10 to 30, then you will use this formula. And when the SPT value is 8 to 32, then use this unit weight. And the sand type, when the sand loose and well graded, then we will use unit weight of this. When the unit weight of soil is clay, then we will use this unit weight. And the soil type, when the sandy, dense, and graded, then we will use this angle. And when the angle internal friction in SPT, when the SPT is 10, then we will use the angle 30 to 35. When the SPT is 10 to 30, then we will use the density soil is medium, and the angle will be 30 to 36. When SPT 30 to 30, then will be medium, and 35 to 40. So bearing capacity factor, angle friction, you can see when the factor is 30, then we will NC equal to 37, NQ equal to 22, and gamma equal to 30. And this is for Terzaghi's bearing factor. When we will use the Meyerhoh factor, then we will use 30, and this is 30, and NQ equal to 18, and 15.7. And Meyerhoh capacity for deep foundation, and Meyerhoh value NQ for driven drill shape. So this is the value NQ. On the 30, then driven for 25, and drill 12. We will use the drill and driven consequently. The question we are seeing here, and below between 8 to 15, the steep, and S1 to 2, and all the relation is given here. Factor of safety here the for shear failure, for earthwork and dam fields, and factor of safety 1.2 to 6. The shear retaining wall 1.1 0.152 2. The seating and coffer dam for 1.2 to 1.6, the board excavation 1.226, and mat foundation 1.7 to 2.5. Uplift for footing 1.7 to uplift heavying and piping 3 to 5. So these are the we can see here the elastic modulus we can see of the soil properties. Okay, so we can see here is the relationship of k minus between k into k naught. The recommended value of k 2.1. We can see here the another we can see here. Okay, this is the we are there are some type of piles. You can see the sheet pile, concrete pile, wooden pile, and composite pile. Here is the ace pile. You can see here the steel pile and the driven pile, and we can timber pile also here, the composite pile. The pile installation is very this figure is given here. The pile driving operation, the load bearing capacity of single pair with skin friction and tip bearing. We can see here the load bearing single pair. We can calculate in this how we will calculate the general equation coming from here. The point of bearing capacity, you can see the example here. The frictional resistance formula is given here, and the allowable load is given. We are using Meyerhoh method to estimate QS on sand. You can see here the Meyerhoh method of estimation on sand. This is the graph, but we will not use. This is the Meyerhoh equation for NQ. For getting the NQ 30, then NQ will be 56.7. And in this way, here is a Jambus method, but we will not use Jambus method. The angle of psi is shown is here. You can see here psi, the angle, the bearing capacity factor will be Jambus method. The Jambus method, but we will not use Jambus method. When the phi is 30, then Jambus method, and C and Q equal to 10. Okay, correlation of SPT value, this is but we will not use. The frictional resistance of sand, you can see the same or the remain same. And the frictional resistance of sand, this is the frictional resistance Fs cannot phi. This is the relationship, and so many things. So let's start. So the theoretical theory and formula of pile bearing capacity has completed. Now we'll see the skin rate or frictional resistance of pile of clay soil. So we'll give the bearing capacity of clay soil of the pile. So let's see how we'll calculate the skin resistance of clay soil. This is an example. So let's read the question first. An individual cast in situ concrete pile in soft saturated clay having the diameter of 0.8 and the shown figure below, calculate the skin resistance of the pile. You can see here is the figure. The shape resistance, you can see QS1. This is the layer 1, 2, 3. That's why 1, 2, 3, and QS equal to QS1. Yes, 1 QS equal to alpha into CU. Then the alpha is 0.5 is taken, is a memorizing frictional coefficient, and CU is given the 50, and S1 equal to perimeter into H. Perimeter we know pi d into H equal to height of the layer, and found 10.05, and S2 this layer second layer. Alpha is a coefficient addition factor, is a constant value 0.50, and C equal to 30 is given here. And also S2 is perimeter into height. Perimeter pi d into height is a layer of the soil, which is 6. And in this way QS2 is funding is here. So now we'll calculate the total resistance with QS1, QS2, and QS3, and found 697.5, and we'll divide the factor of safety is 3, and it is found 252 or 232.5 kilonewton. So So let's see another example. This is the clay soil. Let's see another example. This is the clay soil. So we are finding this. Now the skin fraction resistance of pile in sandy soil. So let's see the sandy soil. This is the sandy soil equation. An individual cast in situ concrete pile in sandy soil. So sandy soil, and having the diameter of the shown is the friction below. Calculate the shaft skin resistance of the pile. So we will see the only skin resistance. There is a two layers, 7 and 6 layer, and loose soil and medium soil. So critical depth of cell loose cent, we can see the loose cent as 10d, which is 10 meters. So this is 7 meter, and it will be 3 meters. So it will be 10 meter. This is the 10 meter. And sigma b is this point is 17 is given in minus 9.81, which is the unit weight of water, and 7 is the layer, and found 550. And this layer equal to 550 plus 18, which is given here 18 minus 9.81 into 3. Why is 3? Because we are getting that 10 milli. That's why it is remain the 3, and found 74.9 kilonewton per meter cube. And critical is the remain same. So now we'll getting sigma b equal to sigma b1. This is the b1, and this is the b2, plus sigma b2. This is the b2, this is the b3. A critical and critical plus critical. So critical plus critical, and found this value, and sigma vertical is 163. Case the two type of layers. So case 1 and case 2. So case 1 is 0.71 into k naught equals what is k naught? K naught is 1 minus sin theta. Sin is the theta is value is 20, and another theta is 30. So 0.70 k2. So the k2, the phi is value is given 30, and found 0.80. As1 into pi d, perimeter into height, and perimeter are the same. The height is 7, and another height is 6, and found 40. And we'll use 10 phi 1 and 2, and found of 0.59. And the skin resistance of the pile will be qs into as, which is k as equal to gamma vertical 10 phi equal to as, and found 317 kilonewton. And you will use the factor of safety divided by 3, then it will be almost 1000 kilonewton. So so our sandy soil has completed. Now we'll see the bearing capacity of sandy soil using Terzaghi method. Okay, so let's see the Terzaghi method. This is the sand and clay. So both layers. On the other hand, we have seen the at first clay layer, then sand layer. Now we'll see the clay and sand both layer. Okay, so let's start. This is the very important. So we can see here the three type of layer is given: the dry sand and clay. So the first two layer is sand, and then clay, and then sand. So it is gone down and down. So we can see all is given. So k is equal to 0.80 k naught, sigma and phi equal to 0.40, q star 220 for when the phi equal to 40. Then we'll find out the q naught from the chart of the Meyerhoh or Terzaghi. Okay, this is the Meyerhoh equation. I am using Terzaghi naught. It will be Meyerhoh. I am missing here. Okay, so let's see here. It will be a Meyerhoh equation. So critical depth we have to find 10 into d. D is given here. The 500 millimeter, it will taken divided by 100, which is taken the meter, which is 10 meter. So the critical depth will be 10 meter below. So this is 4 meter, and it will be added 1 meter. So this portion will be 1 meter, 5 meter will be critical depth. So let's see here the critical depth. Sigma vertical, we know the uh, dry unit at 17 and 4 plus. Now we'll take the 1 meter, which is 17 into 18. 18 is given here. The saturated unit at 18 minus 9.18 in 1 and found 36.95. So, and all the critical depth the sigma critical will be remain same as the critical depth is we found 10d. That's why for transient, and it will be 10 feet meter from top. On a critical depth, DC is 10d for loose sand, for the medium sand equal to 1d to 15d, and for dense sand equal to 20d. Okay, so let's see the assume. Let assume from 0 to 5 saturated 17 and 7 to 8 is equal to 18, and we'll assume Z. So QS, we know the layer 1 2, this is the layer 1 and 2, and found the delta 4 and 1 because this is the critical depth of 1, and 3.5 is this is the layer 3, so we'll use 3, and 3.5 this is the layer, and this is the last layer, and 3, and found as is nothing but perimeter into height, which is pi d into 4 and 1, and in this way we will calculation here, and phi is given the here k is equal to 0.80 0.801 minus sign 5 equal to is given here, all the phi is given here, and putting all this below. This is the gamma sigma b equal to gamma prime df. So the first is 0, we can see here the first is 0, and second one into 28.76, and we'll divided by 2 for taking the average value here, and the second one layer 2, this is the 28, so you can see here 28 and 39.5, and divided by 2 and found 32.85, and 36 plus 36 divided by 2, and 36 plus 36 divided by 2, and found here 10.705. Phi is given here, and found 29 and 39 in this way we will found. QS we know K as gamma prime into 10 phi, and putting this value and found here, and Q S equal to Qs into AS, as we have found the AS value is here, and QS value is here, so we will multiply value and putting here, and total QS equal to 15.52 kilonewton. Okay, for clay soil we know QS3 as 3, and found 19 here, and total skill resistance equal to QS1 QS2 and QS3 and Q plus clay, 1 is clay, we can see here this is the clay layer, and found 73, and QB, which is the in bearing capacity QB into AF, QB equal to C and C star and Q star AB. So this is sand, that's why we are not using C and C star, which is time C. As we can see, and this is the tip which is sandy sand, and that's why we will use this formula only sand, which is 16.92, and found 2976, and the ultimate bearing capacity will be skin resistance and in resistance. So skin resistance we have found 17, which is 78, and in bearing we have found 2976, and found 7054, and we'll if we get the ultimate load, then we will divide it by factor of safety 3, and we will found 10 approximately 1000. Okay, let's see another example which is given. Okay, this is the question. Now we'll seeing here the determine the ultimate bearing capacity of single pile, which is length 10 meter and pile diameter 800. The tile was a bore pile in casting type, and given information K as is bore pile is 0.80 into K naught, and angle of friction in casting rate 0.805, and adhesive factor alpha equal to 0.40, Cu equal to 0.45 K, and based on analysis experiment evidence, and C may be taken to 9, and resistance, recalculate the ultimate bearing capacity if diameter is 1 meter. So we can see here the graph is here is a question is given here phi 1 2, and this is the graph between angle and NC. Okay, so we know the ultimate will be in bearing and skin resistance. So in bearing, we know NC star and Q star. So NC star is 38. We are taking from this curve, and NQF and stand taken from this curve. On theta with respect to theta. Okay, and found 3120. Here is the NC star 38 and NQ is 18, taken from this graph. NQ is 18. Now Q equal to gamma prime df. So this is the Q and Q. So if you NQ is taken 18, which is 18. This is the 18. So our angle is 25. So if we go to the 25 angle, then we found the intersect this point and found this is NQ. So NQ is 18. We have used NQ star 18, and in the same way we use the 15 this curve and found NQ NC star and found here, which is almost 38. So this is the 38. So these two values are taken from with respect to angle. So let's see the critical depth as the 10d, which is 8 meter. So this is the 8 meter. Gamma naught is 0 and gamma 2 equal to 16. 2.2 minus 9.81 into 6 is the layer, and found 38.3. And the another critical one 3 is 38.3 plus 72 into 2 and found 52.8. So gamma vertical will be this one divided by 2, this one divided by 2, and sigma 2 into sigma 3 divided by 2. So QS equal to alpha CUS 1 K naught 1 minus alpha gives and 10 theta, and putting all these below and found 192. And Q ultimate will be in bearing and skin fraction, which is 3120 and 192, and found 3312 kilonewton per meter square. Okay, these are the method is in that. So if we go to the beta method, this is the another method. So let's see the side resistance of coefficient of beta method. So this is the another method. So our main topics has covered. Now we'll see the bearing capacity of pile sand and clay on beta method. So let's see as the beta method. They calculate the nominal side resistance for the layer of fine grain between depth Z of 33 and 40 using the beta method. So this is the another method. So total weighting of the soil estimated 122. So subsurface area. So all the data is given here. At the center of the fine grain, we can see 15 into 18 into 7 divided by 2. So this layer we have to calculate it and found 18. Okay, gamma prime into gamma d into gamma prime into Z, and found 30, and phi equal to we know that according to the BNBC as to ACI 318, the phi equal to 27 in 0.5 into 10.2 log into N160, and putting all these value and found 40. Another method for getting the phi value 20 into root over 15 into N60, and found 38.6. So but this is not valid, I have not shown, but this value is found ACI 318 and BNBCT in others guideline. Okay, so you can see sigma P divided by PM equal to 0.40 and 160. So P is taking here, so 0.40 and 160, and putting all these value and found 7100. So our consideration ratio sigma P divided by vertical and found 2.69, and Kp coefficient of passive 1 minus sin phi divided by 1 by sin phi, and found this value, and cannot 1 minus sin phi into OCR sin phi greater than passive by passive, and found 0.62 which is passive, we have found 0.62. So this is the okay. Beta method, so beta is k into 10 phi and found 0.62 into 10 phi which is 0.52. So f prime equal to vertical divided by beta and found 1500. So the skin resistance phi d into delta z into Sn, which is phi d delta z Sn v into beta method, and putting all these below and found 625 kilonewton meter. Okay, so let's see another example. The calculate ultimate resistance of the soil drill bore shaft, and the shaft is use the beta method. This is also another is beta method. We can see the profile is given. Now we have to divide the 5 strip. So we can see here is the soil profile, but we have to divide the 5 strip, which is 20 feet for the precise below or overburden pressure. So we are intentionally divided all the soil profile in 5 meter strip. Okay, so let's see for the 5 strip for getting the precise below. Okay, the skin resistance 1 to 20. So this is the 1 to 20, 1 to 10 and 20. It will be here, and found gamma vertical 10 into 10, and found this, and sigma p 0.7.40 or p into n60, and found 3742, and over concentration ratio 3.2, and Kp is a coefficient of passive, and found 3, and K naught which is found 0.92. 0.92 is less than Kp, so this is okay. So we'll use 0.92, and phi equal to 30, and beta is k minus phi equal to 0.53, and k naught equal to gamma vertical beta in S surface. Surface is nothing but the perimeter into height, and found 142. And in this way we will calculate the for 20 to 40, and found 2 keep, and for 40 to 60, this is the 40 to 60 another layer. We are dividing all the layer for getting the precise value, and found 436, and for 60 to 80 and 80 to 100, and found all the value is here. So now the total resistance will be a summation of the all values, and found 1827. Then and the second question is nominal yield resistance Ne 0.60 into N60, and found 20 ton per feet square, which is less than 30 ton per feet square. So this is okay, and yield resistance will be 0.60 N60 into AB, which is 60 ton or 31 ton equal to 60 ton. The ultimate resistance equal to 1827 plus 602, which is 2429 cubic feet. Okay. So let's see another example here. This is the example we are seeing. Calculate ultimate resistance of the length is given, and clay soil given. Use the beta method. This is also beta method. So now we have to divide only sand layer. So this is the sand layer. We are not using clay layer. This is the clay layer, and this is the clay layer. But we are saying that this is the sand layer. So this is the sand layer. So this sand layer for getting precise value of overburden pressure. So we're dividing 1 to 3 divide in only sand layer. So 0 to 5 we know the alpha cu as, and putting the value, and 50 to 100 which is clay alpha cu as is perimeter into height, and found 1037. 30 to 20, this is the sand layer, which is vertical 10 into 20 into 100 minus 62.5 into 30 and 100 into 50 and 20. Putting all this value, and found 6625, and sigma p equal to 8590, and over concentration ratio 1.3, Kp equal to 46, and K naught equal to 0.42, which is less than 46, so it is okay, and beta equal to we have found 0.35, and putting the beta in 5 into alpha bts, and found 583. So in this way we will calculate the 120 to 40 in cent, and 140 to 150 for cent, and putting on this value, putting all the total resistance value, and found to 9420. And the normal yield strength, which is 20 24, which is less than 30. So this is, we can say this is the okay. In resistance we can see the 31 ton, or which is 602 kip. The ultimate resistance we can see here the 3522. So uplift capacity 40 into point, and skin friction into weight, we can see here the in bearing capacity formula, the limit value sum of the, we can see the limit skin resistance for KSF in boarding 30 TSF, and for this equation 0.60 and 60, and the limiting value MB equal to 3. Okay, so I hope this lecture is intended for only for pile. Now we'll see the group pile. Okay, let's see. Okay, this is the group pile. You can see here the group n into individual. N is the efficiency factor. Group 1 into group 2 has a pressure valve is separated. Here the pressure valve um, over from one in another. Pile to pile spacing is S2, and the pile to pile spacing is less 1, and S1 is less than S2, and the efficiency factor 1, and the efficiency factor is less than 1, and group 1 less than group 2. So here is another capacity of group pile using Terzaghi method. So we can see use group skin friction of group, skin friction of in bearing of group, so skin clay and sand. So using this formula 2Lg 2Bg plus delta Cn for skin, this equation, and for in bearing we can see clay and sand as the clay, and for sand using this 9C LGBG into 9C. We can see here is the LG is nothing but m into n of number of spacing minus number of spacing in m direction, and number of spacing in n direction, plus dia of pi, and Bg number of spacing in n direction, and number of spacing n direction, and dia of pi. Lg m plus spacing in m minus m spacing in n plus d. Bg n into spacing in n spacing in n plus d. This is the basic equation we have now. The part we using the pile efficiency factor method, n equal to 1 minus mn minus plus mn plus n 30 into 90 into theta. M is we can see here. Okay, so now we want to see the group pile. Okay, so let's see, here is the some theory of group pile. We're seeing here the theory of group pile. This is the pressure valve. We are showing isolating of the single valve and isolating of the group pile and highest, and the pressure isolated isobar of the piles. Maximum spacing of piles of group we can see here. Here is the typical arrangement of group piles in group. This is the 3, 4, 5, 6, 7, 8, 9, 10, 11 piles and 12 piles. The pile arrangement. Okay, with the pile groups we can see here. The efficiency load bearing capacity of pile group may be defined Q equal to Q and the asking ball LGBG into L, so individual. So this is the LLL and total L equal to L and total B equal to BG. So Lg equal to n1 minus 1 into d into t and bg into n2 minus n into vt, or we will use this equation. So this total length is, we can say, Lg, and this total length we can say bg. Okay. And the group efficiency factor we can see here, n equal to this value and found ultimately here, and q equal to ultimately found this value, and n equal to using this equation, the pipe group efficiency equation, you can see converse Laver's equation, Los Angeles group equation, is KT equations. That means there are so many equation. Particle capacity of group pile you can see here. Here is another particle capacity group pile sand and gravel. We can see the phi 30, 40 and 55 and L by D, and efficiency factor will taken from this chart. Also particle capacity factor we can see here. Here is the L by BG ratio, 1, 2, 3 and ultimate, and we will found NC value from this chart. So let's see. Here is an example of group pile. The theory is in that. Now the bearing capacity of group pile using efficiency and Terzaghi method. We will see this portion. So the arrangement of the 12 pile in a group and the soil profile are shown below. The pile diameter 1 meter and the length of pile 15 meter, and center to center spacing 0.9, alpha equal to 0.45, K is equal to 0.40, K naught, K sigma phi equal to 0.40. Calculate the capacity of individual pile. At first, L when dia 1 meter and L is 15 meter and the soil profile are given, and calculate the capacity of pile in the group of pile. Okay, and the group of pile in vertical pile subject to an eccentric force is Q is given the magnitude 4650 Newton. Q is located 10.20 meter along x-axis and y 0.40 and z-axis, always from the center of the pile. Identify the piles in carrying to the maximum and minimum forces of the pile. So we can see here is the pile A, B, C, which is D, E, F, G, H, and this is the 1, 2, 3, 4 row and 3 vertical 3 column. As we know the 12 pile. So the pile arrangement is here, and column is eccentric load is given here. So this is the clay layer and sand layer, clay layer. Now we'll calculate the we know the ultimate load will be yield bearing and skin bearing. So yield bearing will be QS equal to alpha S. So 9C into A is equal to pi d square by 4 and found 601 cubic feet. And the skin resistance we know the critical depth of footing 10D, which is 15 into 1, and found 17 minus 2.2 9.92, need to use 72.9. This is the point, and 73.9 plus 72.2 minus 9.8 into 30 plus 13. This value will be here, and ultimately 3 value is found. The sigma vertical 3 is the critical depth. Okay, so let's see Q equal to S, alpha Cu S, alpha is value, Cu is value, and S we know the pi d into S, K S, sigma B. This is the B. The portion of B value is considering 1 minus 5 by 70 is given here, and 10 minus 5 into 70, and given all these value and found 676. The capacity of individual file we can know the in bearing and shaft, which is 1238 kilonewton, but we will calculate the capacity of group file using efficiency method. We know the here the efficiency method 1 minus mn minus minus m, mn minus m into 9 to theta m, which is x x-axis, which is 4. When we see in the x-axis, we are locating for this way and found how many how many how many piles we are seeing the 4, 1 2 3 4. So that's why we will use the 4. On the other hand, and when we will see the on y-axis or vertically will you seeing this pile, then we will found 1 2 3. That's why we will use the n value is 3, and dia of we can see 1 meter, and this pile to pile is spacing 0.9, and theta equal to tan inverse t minus d, and found 48. And putting on this value and found the efficiency factor 0.25. And now we'll use this efficiency factor, which is individual and number of pile and efficiency factor. We know the individual we have found 1238, and number of pile is 12, and efficiency factor is 0.25. And now the value, the ultimately we have found 3712 kilonewton. Okay, so now we will again the using the efficiency method in Terzaghi method, because we have using this efficiency method, which is the factor method. In the same method we will use the Terzaghi pile method. So you can see this is the all method is given, the LGBG. This is the LG in x direction. This is the vertical position, which is the BG. So LG, we can see number of spacing and number of spacing in n direction, in m direction, and m direction, and dia of pile, and putting on this value and found 9.9. And BG is efficiency number of factor and spacing in n direction minus spacing of n direction into dia of pile, and found 4.9. And putting all this value, alpha C LGBG delta H, and found 9457 kilonewton. In the shaft of resistance of piles capacity, we can use this formula. Before we putting this formula, we have to find out the critical depth, which is 10 into D, and found 10 and 10. When the depth is 10, and found 17.2.9 minus 9.9, which is 7.93, and for 13 and found 29.56. And putting all this value in this formula, and found 241 kilonewton. And for the skin friction, and Q clay plus Q sand, and found 9698 kilonewton. And group in bearing, we know the 9C into AB, and AB equal to LGBG, and found 5999 kilonewton. And the ultimately it will be skin group into in bearing script, which is 156,692 kilonewton. And total number of pile will be divided. So if we calculate the ultimate individual and divided by total number of piles, we know that 12, and found 1304 kilometers. So ultimately what we will get, ultimately we have get the two results, which one is the capacity of pile, which is 3714 when we use the efficiency factor. On the other hand, when we have used the capacity of group pile using Terzaghi method, then we have found 1569 kilonewton. And the capacity of group pile we have been seen here, 37114. So we'll use 3714 because this is the smaller value. Okay, 190. So 190. We can see another example. This is another example. 193. So an arrangement of 12 pile in group, and the soil profile is given in the center of center spacing is 0.9. Calculate the capacity of individual pile when this equation, when the group pile of particle subject to the eccentric for magnitude for 260 kilometer, 2600 kilometer, and Q liberate. All this data is given here. We can see here is the data, the T bearing capacity 707, And now we'll calculate the critical depth, which is 15 into d as the medium dense, and found db and d3 and db. So we'll use skin resistance alpha cu as for clay, k as sigma prime, b k as a as for sand, and use this find 1280 kilonewton, and the capacity of individual pile will be 1970. Now we'll use the efficiency method. We know the m equal to 4, because when we'll see from horizontally, then we'll in x direction found 1 2 3 4. That's why we will use the 4. When we will see the in the column direction vertically or y directionally, then we will see the only 3 file. That's why we will use n equal to 3. N equal to 3, and diopile is given, and c equal to given, and theta equal to, we are using this, and efficiency factor we are using all the dimension and found 0.20, and the capacity of group pile you can see here 5960 kilonewton. So we can see another example here. The factor of safety is 3 required to the group pile is shown here. Find the maximum and determine the pile acting in the individual and pile acting in the group. So we'll using individual and group. The piler L is given, size is given, and given in clay. So Q individual in bearing plus skin friction, and in bearing equal to 9 CAB, and skin friction alpha CVS, and putting this below, and found 9587, and Q individual available individual will be divided by 3. This is the factor of safety, and 32. Now we'll using m equal to 4, because when you will use looking from x direction, then we'll 1 2 3 4. That's why m is 4 and n is 3, and d equal to 1, and theta equal to 18.43, and eta efficiency factor will be 0.71, and the individual allowable group capacity will be allowable into number of pile into 0.7, which is 273 kilonewton. Okay. Now we can see another example here. We can see another example here. The factor of safety is 3 required to the group pile of the shown below. Find the maximum load of the determined by the piles of acting individual and piles of acting the group pile, and the pile length are 20 million diameter 0.3. The driven pile clay of Q equal to given here. So we know the individual Q in bearing into skin resistance. So in bearing 9 CAB to skin resistance equal to alpha CUS, and putting all these below, and find 520, and individual local factor of safety we are dividing factor of safety, and found 173 kilonewton. Now we will use the efficiency vector m equal to 3. We are looking from x direction 1, that's why we will found 1 to 3, and n equal to 3 is also we are looking from y direction 1 to 3, and dia is given 0.3, and d equal to 1 meter is given, and theta equal to 16.7, and efficiency factor putting all these value, and found 0.087, which is less than always less than 1, and individual group file is after the filling the all the formula, and found 136 per kilonewton. Okay, so we can using complete this formula using Terzaghi and efficiency vector. Now we'll use the beta method. So we can use the beta method here. 37. Okay, so this is the group file you can see here. We'll use the beta method. Calculate the ultimate resistance of the 12 pin and group drill shaft and bore pile. As die is diverse sandy soil is given, hose the water below as a distance and both is given here. So you can see here is the given, we have to divide the 5 strip of the precise, and skin resistance is same in remain. Kp is our consolidation ratio, and Kp is 3, and K not equal to 0.92, which is less than 3, so it's okay. So K equal to K not, phi equal to 0.3, and beta equal to 0.53, and K is can equal to 109. And for 20 to 40 feet for sand, Kb equal to 2670, Kp equal to 3742, over consolidation ratio 1.4, Kp is a passive coefficient is 3, and over K not equal to less than 0.59, which is less than 3, so okay, we'll use skin affection is 171 kip. For 40 to 60, same way you will calculate, and 60 to 80, and 80 to 100, and the same way you will calculate. Now we'll now we'll now we'll adding the wall value, and found 1299. The normal yield stress is 20 ton per feet square, which is less than 30, and the yield resistance is 170 ton, which is 340 kip, and the ultimate resistance, so we can see the skin plus yield resistance 1639 kip. When we will use the efficiency factor, n is 0.65 for center 2 point D, n equal to 1 for center D equal to 4, and for 3D, now we'll use the 3D, and efficiency factor is found 0.77, which is less than 1. Now we'll using efficiency factor in sandy soil, n equal to number of pile into Q individual, and found 358 kip. Okay, so here is the same another method we can see here for clay soil. I'm not explaining it here because I'm already said that. So now we'll see the another so you can see the this lecture is in. So last one we will calculate the maximum and minimum vertical load on pile. So let's see. Okay, so find the maximum and minimum vertical load on the pile in group pile and given below. So you can see Q1 equal to 15, and Q2 equal to 200, and AM2 equal to 1750, and the pile arrangement is given here 2 and yield is 0.5, and we can see the here the C1 ZS section and CD ZZ section to each pile CG. So CL equal to ZZ section to the CG of the column, and CD is a ZZ section to the CG of the column. IZ equal to ZZ section to pile CG, and equal to total pile section. So we know the Q1 equal to Q1 plus Q2, the force is given here, and CL equal to, we can see here 2 divided by 2 plus 0.5 into 2 is 0.2 is given, so 2.3. Okay, this is the ZZ section, or this is the ZZ section, and 2 divided by 2, this is the 2 divided by 2, and plus 2, and plus 2, and 0.5, this is the 0.5, and minus 1.2, and minus 1.2, this is the minus 1.2, so this is the CL value 2.3, and E equal to Q1 CL plus Q2 CL plus M2 divided by Q1 plus Q2, and 1.89, and M equal to force into perpendicular distance for the summation of force, and found here, and IZZ we know the set, and ZZ section to the distance to the CG, and found 40 2 into 1 cube, so this is the 2 into 1 cube, and 2 into 3 cube and found 40, and qi equal to summation of q divided by n plus minus m into di, and qc for c this pi found 30 into 8 plus 3990 into 1, di equal to 1. So this is the 1 because the distance of the zz to the pile is 1, 2 divided by 1 is 1, and d equal to 3. Why 3? Because the depth d is the located from this distance to this distance, we can say the 3. This is the 2 divided by 1 plus 2, this is the 3. In this way qb and qa we will use this. So after using this formula we'll find the 510655 and 656 and 220. So maximum load is taken d, so we can use the d. So maximum load has taken the d, which is the far away from cg, and the minimum taken the a, which is that taken, which is 220 kilonewton. So if we want to understand the izz, which is 1 into izz is nothing but izz is how many piles we are seeing in the x section. We are seeing the in x section only 2, so this is the 2 into distance of the that pile. So distance of the that pile is 1, so that's why 1 cube. And in the same way we can see the how many piles seeing in the x direction is 2, and distance from cg to here we can see 2 into 2 by 2 is 3. That's why we will using this 3, and we are multiplying 2. Why? Because this is the left portion as the same as the right portion. That's why we will multiply into 2. So I hope that you can understand. Thank you everyone. If you have any question, then let me know. I will try to answer your question. Thank you everyone.